Hello and welcome to DynaLearn. This video is about understanding climate change risks to cities. It focuses on the representation of structure and behavior which are introduced in Learning Space 2. Climate change is causing rising sea levels which is threatening major cities. It can potentially damage billions in property and endangers millions of people. The learning goal of this video is identify the components that play a role in a system. So how does DynaLearn help you identify such components? DynaLearn models distinguish between structural ingredients and behavioral ingredients. The structure identifies the system and remains unchanged during simulation. By contrast, behavioral ingredients describe those aspects of a system that change. So how are structure and behavior modeled in DynaLearn? Let's start with structure first. There are three types of structural ingredients. Entities are structural objects that define the system. Examples of entities are a population, a bathtub, or the atmosphere. Configurations are structural relations between entities. Examples of configurations are lives in, such as the bear population lives in the forest, above, such as the faucet is above the bathtub, contains, as in the bathtub contains water, and preys on, as in the bear population preys on the salmon population. Finally, attributes represent the properties of entities. For example, a power plant can be of a particular type, such as coal, gas, or nuclear. So let's see if we can model the structure of the system causing an increase in sea levels. The distinction between structure and behavior is introduced in Learning Space 2. So I will start a model in that learning space, which I will call sea levels. I want to model that the carbon dioxide in the atmosphere increases the greenhouse effect, which causes an increase in the temperature of the Earth, which causes the ice in the ocean to melt, which increases the sea levels and causes flooding. So there are several important entities that have to be modeled. Let's start with the entity Earth. To add an entity, I press the Add Entity button on the left. I then get a pop-up in which I can name my entity, in this case Earth, and then I can press this button here to apply these changes. And now I have an entity Earth. Instead of using the button, I can also go through the Ingredients menu and select Entity here. Note that this also shows a shortcut which I can use to develop entities faster. I will call this entity Atmosphere. Now I will use the shortcut, Ctrl E, to add the ocean, the ice, and the landmass that is being flooded. So, ocean, ice, and landmass. Now I want to relate these entities using configurations. Let's start between a relationship between the Earth and the atmosphere. I can click on the Earth entity and then shift-click on the atmosphere entity to make the Add Configuration button active. I can press this button and then I can name my entity. In this case, has. So the Earth has an atmosphere. And then I press this button, Save Changes to Model, and the entity appears. The Earth also has an ocean and a landmass. So to add these configurations, I select Earth and Ocean. And instead of using the button, I can also go through the Ingredients menu, where I can see that I can press Ctrl C to add a configuration immediately. I will reuse this configuration has, so the Earth has an ocean. And Earth also has a landmass. And now I will use Ctrl C, has. I will move the ocean here so that the relationship doesn't overlap. And finally, I want to say that the ocean contains ice. So I select ocean and ice, add a configuration. Now I have to add a new configuration definition. And then I have to name it contains. And then I press the Save Changes to Model button and I have the relationship contains. Let's say that I want to indicate that the landmass is not interconnected, but is separated. I can do that by adding an attribute. So I click on landmass and then the add attribute button becomes active. I click it. I name my attribute interconnectedness. I add two values, and the first I will call interconnected and the second I call separated. And as I mentioned before, because attributes are part of the structure of the system, it does not change during simulation. So I press the Apply Changes button to add the attributes. So now let's see how behavior is represented in DynaLearn. The behavior describes those aspects of a system that change. The most important ingredient to represent the behavior of a system are quantities, which represent the changeable properties of entities. Each quantity has a derivative that indicates its trend. A quantity can be either increasing, steady, or decreasing. Examples of quantities are the predation rate of a population, its biomass, the height of an oil container, and the heat flow between two objects. So how do you model quantities in DynaLearn? We will start by modeling the carbon dioxide in the atmosphere. To do that, we select the atmosphere, which makes the Add Quantity button active. And if we press this, we can create a new quantity called carbon dioxide. And we press the Apply Changes button. Let's now model the greenhouse effect, which is a quantity of the Earth. Instead of pressing the button, I now go through Ingredients, select Quantity. I can see that Ctrl-Q is a shortcut to add quantities. I get the same dialog. I create a new quantity called Greenhouse Effect and press the Apply Changes button. Let's say I want to have an opposing effect which decreases the greenhouse effect. So I model the reflectivity of the Earth, which is called albedo. So I select Earth again. I now use Ctrl-Q to add a quantity, add a new quantity and call it albedo. I will move my entities a little so that it fits better. And now I will model the temperature of the Earth. I see that my ocean and ice entities are in the way, so I'll move them a little to the right. Select Earth and add a quantity temperature. I see again that I don't have enough space, so I'll move my landmass a little to the right and my ocean and ice as well. And now I will model the amount of ice in the ocean. So I select ice, add a quantity, click on New Definition, name it Amount, and press Apply Changes. And now I've modeled the amount of ice in the ocean. The ocean has a particular level, so I select Ocean, add a quantity, name it Level, press Apply again. And finally, I want to say that the landmass can be flooded. So I will add a quantity flooding to the landmass. And I think I have now modeled each of the important components of the system. So to conclude, DynaLearn enables you to identify the components of a system. It does so by distinguishing between structure and behavior. The structural ingredients, such as entities and configurations, identify the system, while the behavioral ingredients, such as quantities, represent the changeable properties of systems. In the next video, I will show how you can add causal relations between quantities to be able to run simulations.